Now we look at how to use the table to find the probability of the standard and normal distribution. So first, let's look at this picture here. There's this is pic graph of a normal standard distribution. The mean is 0, and now this number right here on the left side of 0 it's negative 1.9 for the standardized variable, so z. So z, again, recall what we learned before. Z is a standardized variable converted from a random variable. So here we want to find out the probability of z less than or equal to negative 1.9. Again, we never for continuous variable, we never ask the question of probability of something exactly equal to something else. We always ask the probability of something less than equal to or greater than or equal to or between two numbers. So we're going to look at these three different cases. So first we want to find out the probability of z less than or equal to negative 1.9. And so from what we learned in algebra class, that less than or equal to must be on the left side of negative 1.9. So this and also the definition of the probability of continuous random variable, it's the area under the curve. And again, we cannot use calculus. We won't use the calculus to do this. We have to use calculus, but since we have already had a table calculated before, so we can look at how to use the table to do this. So we go back. We're gonna look at the table, which is posted under Blackboard, and if you have a book, it is also on the back of the book, the appendix for the standard normal distribution probability. So if you click on this link and you go to this page, and so this is the pig table here. And always remember, this table only shows the probability for z less than or equal to a certain value. So if it's greater than or equal to, or if z is between two numbers, we have to do some conversion. So the first case, like in the homework, in section homework 6.12, 6.12, we want to find the area under the standard normal curve to the left of some number. So like in this picture, shaded area, it's we want to find the area of this under this curve to the left of z. And go back to our slide. We want to find out the area to the left side of negative 1.9. So we have we look at the table here, negative, so it's negative 1.9. Okay, so if we find it right here, 0, 0. So the answer is 0.0287. So what if I want to find out the probability of z less than or equal to negative 1.93? So okay, so we find negative 1.90, because if you look at this column, we don't have negative 1.93, but then we will add, we go look at here, 0.03, because this is negative 1.0 and 0.03 is negative 1.93. So we look at this column and we get this number right here. So it's for the probability 0.0268 for negative 1.93. Okay, or you can say this is 2.68%. And again, it's similar to binomial distribution. Although it didn't say this is less than or equal to here in the table, but from the picture you know this is less. This is the probability for capital letter Z less than or equal to this little letter, this small letter Z. Okay, so capital letter Z and the small letter Z, they're different. If this confuses you, you can think of Z as using a different letter, say C or something. So here these numbers are like this little z here, not the capital Z. So this doesn't mean Z, capital letter Z, equal to negative 1.0 or negative 1 point something. It means the probability for capital letter Z less than or equal to negative 1.3 or negative 1.393 or something, negative 1.9 or so whatever. So we can do another one. Say, what if I want to find out the probability of negative? Well, this time we can do positive. Then we go down to next page. This is the table for positive, and positive 2.37, for example. So the probability of Z less than or equal to, again, one more time, it's on the left side of this little Z, less than or equal to 2.37. So I found 2.3 right here, and I found 0.07 here. So the number is right this one, 0.9911. So the probability of capital letter Z less than or equal to 0.9911 is the probability of capital letter Z less than or equal to 2.37 is 0.9911, or you can say 99.11%. Okay, so this is on the left side. You can see the shaded area. It's the left side of whatever the number given. So 2.37, the number I gave you, it's like this little z. So the capital Z is less than or equal to this little z, 2.37, whatever the number is given. Okay, so this is how you do 6.12. And 6.14, it's looking for the area to the right side, under the curve, to the right side of a number. So if I want to find out the probability of capital letter Z greater than or equal to 2.1, so let me write down here. We get rid of this. So the one we did before is P, capital letter Z less than or equal to. Sometimes equal can be omitted because, less than or equal to or less than, it's always on the left side of negative 1.9 here, so it doesn't make a difference. So what we find out is 0.0287 from the table. And now let's try to do probability of capital letter Z greater than, or you can say greater than or equal to 2.1. So now how do I find out this? Because again, you cannot use the table directly because the table only tells you the left side. So the table only tells you the left side of the area under the curve to the left of 2.1, not to the right side, because Z greater than 2.1 is on the right side. So what do? We can do a subtraction. Again, the total area on the curve is 1. So from the table, I can find out the area to the left side of 2.1. So if I do 1 minus the area on the left side of 2.1, then I will get the probability of the area to the right side under the curve. So what I need to do is I use the table to find out this probability to the left side of 2.1. So I go back to the table, and the 2.1, it's positive, so it's right here, 2.1 or 2.10. So that's the same thing. So it's 0.9821. 0.9821. and then I do a subtraction because this number is the area to the left side from to the left side of 2.1. So from this line all the way to the left side, so the whole left side area. And I do subtraction again, 0.0179. Okay, so that's how we do the homework 6.14 if we want to find the area of the right side. Use the table to find out the area to the left side of the number and do subtraction from 1, and you get the area to the right side. Now, one more case is we want to find out the area in between. So what if I want to find out the area between negative 1.9 and the 2.1? So it wasn't shaded here. Let's actually look at this example. So the we want to find out the probability of capital letter Z between negative 0.155 and 1.60. So it's the area under the curve between from negative 0.155 to positive 1.60. It's the area shaded here. Okay, so again, the table does not tell us this kind of probability. The table always tells us the left side, the area to the left side of a number. So let's see how we use the table to do it. So what we do is we're going to find out the area under the curve to the left of 1.6. So it's going to be the whole area from right here all the way to here. And then we can use the table to find out the area to the left side of negative 0.155. So it's this white area here. And then we can use the total area to the left side of 1.6 minus the total area to the left side of negative 0.155, and then we get the shaded area. Okay, so let's go to the table. So first I'm going to find out the probability, the area to the left side of 1.6. So this is what we do. We want to find out the probability between negative 0.155 less than capital letter Z and less than 1.6. So what we do is we find out the probability of capital letter Z less than 1.6 to the left side of 1.6 minus the area to the left side of negative 0.155. So let's find out the first one. To the area to the left of 1.6. 1.6 is right here, 1.6, which is this number, 0.9452. So I write down 0.9542 minus the area to the left of negative 155. Then go to the negative part, last page, negative 0.155. Let's double check, negative 0.155. So it's negative 0.1 here, and we go to negative 0.15. Notice that the table doesn't really give us 3 digits. It only gives us 2 digits. So we can only find a negative 0.15, which is this one, instead of negative 0.155. So we're just going to use this as approximation. So for negative 0.15. So instead of negative 0.155. So I'm going to use this 0.4404 as approximation. So 0.4404, and we do a subtraction, we get a 0.5038. And you can see my number is a little bit off from 0.5068 because the table I have is not the complete table. So in this case, this is acceptable. So it's just a small error. It's only 0.003. So the error is very small. Okay, so we can use this as an answer.